let's take a moment and look at this problem. We're given a total amount of energy. We're going to add it to a 125 gram sample of water at 40 degrees Celsius, and it's asking us what the final temperature of the water is. 420 kilojoules is a lot of energy, particularly when you're talking about heating up just 125 grams of water. If we look at the heating curve, temperature versus energy added for water, okay, start below zero, we have the melting point, heating it up, and then we have the boiling point, we heat it up. In this problem, where we're starting really is somewhere in here, okay, about 40 degrees. If I have 420 kilojoules, I think that we'd find if we just said, okay, it's just going to heat up, we're going to end up somewhere like up here, like 800 degrees. Well, that's not going to happen, because all I'm going to do is I'm going to heat the water up to 100 degrees C, and then what's going to happen? It's going to then, if I add more energy, it's going to boil, and then when I'm done boiling it, then it's going to start adding energy again. So what we have to look at here really is how much energy will it take to get to the 100 degrees. I think this is our first step. How much energy will it take to boil the 125 grams of water, and then how much will it take to continue to heat, and at what temperature will I then run out of energy? So what we want to do is really we're going to take this 420 kilojoules, subtract Q1, all right, and if I still have energy left, then we're going to calculate how much it costs, how much energy it takes to boil it. And then if I still have energy left, then I'm going to look at what that final temperature would be. All right, so let's step through this. So for number one, the Q, since I'm heating it, it is a mc delta T. My mass is 125 grams. My C is for liquid water, which is the 4.18 joules per grams degrees Celsius. And my temperature final is 100 degrees Celsius minus 40 degrees Celsius. That'll give me 31,350 joules used. Okay, so that's Q for that first phase. So my Q remaining is going to be, I'm going to just convert that to joules, minus 31,350 joules. So remaining I have 388,650 joules remaining. All right, so that's probably enough to boil it, so let's see how much energy it takes to boil that sample. That equation is going to be H N times delta H vaporization. So I have to get the moles. That's 125 grams times 18.02 grams in 1 mole of water, times the vaporization is 40.67, that is kilojoules per mole. So that energy needed to boil that amount of water is 282,117 joules. So that gives me my Q remaining as 106,532, I guess, 33 joules. That's the amount of heat that I can now use to heat up that vapor. So that's Q3. So I'm going to figure out how I can do this without running out of room. rearranging the Q is equal to MC delta T for delta T. Delta T is going to be equal to Q, actually, Q over MC. So that is the 106,533 joules divided by 125 grams. And the heat capacity for the vapor, for the gas, is 1.84 joules per gram degrees C. So my delta T then would be, so that gives me a total delta T of 463 degrees Celsius. But remember, that is T final minus T initial. Our T initial was 100 degrees Celsius because we were at the boiling point, so the final temperature is going to be 563 degrees Celsius. There you have it.